Yo, what is good, everyone? Welcome back to Stonks Maxxing Day 36. We are. I don't know what we are, but I have about 30 minutes to 45 minutes and want to deep dive into Intel, so this is probably the start of that. Now, there's going to be a huge learning curve. I expect this to be multi parts and maybe 30 or 40 parts in order to, honestly, probably a year or so to fully understand everything that Intel does and understand the technology behind it. I don't even know if a year is going to be able to cut it, but there's some really, really, really big stuff happening in the semiconductor industry. So I think this is an interesting play right now. Intel is currently facing a lot of heat in their stock price in the past 2 years. I think Nvidia, AMD, even Apple have been eating up market share in CPUs, GPUs, data centers, smartphones, and computers. I think Qualcomm is another big one in here. So I've already kind of have something outlined in this Google Doc. Right here, I just pretty much highlighted. Ooh, okay, I actually did not see it. I totally forgot about this. So their strategy, it seems like, and this is pioneered by their now CEO, Pat Gelsinger, to reduce the technological gap in production capabilities with TSMC and Samsung. So he's really betting big on the foundry business for Intel, pretty much contract manufacturing for fabless chip designers, and it's going to require a lot of capex, but I think given today's geopolitical arena, there could be a substantial tailwind from a geopolitics point of view for Intel, as I believe they're ramping up 2 or 3, 4 foundries due to the CHIPS Act. And I want to find a roadmap for Intel. Intel roadmap. Yeah, this is kind of crazy. Okay, so yeah, Intel is investing a lot, and it seems like their foundry business. We'll take a deeper dive into that, but let's take a look at this infographic here. Let's figure down this too. Saying fund. I think company reports. Let's do Intel. Oh, it's a PDF. Okay. Okay, so there's 4 different things. Leading and extending process roadmap beyond 5 nodes in 4 years, 5N 4Y to include new Intel 14A, and several node evolutions to address customers' varying requirements. Okay, now I want to open up GPT, see if we can get some starting points here. I might even look at Google search. So I have a few questions. Let's try to write them down. Intel Foundry process roadmap. Right. So what are the nodes in? So what is the significance of 5N for Y? So 5 nodes in 4 years. Okay. And then how does this stack up against TSMC, Samsung, and Semiconductor Manufacturing International Corp? Because I think those are in Global Foundries, actually. These are probably the top 4 in revenue for their foundry business. Okay. What are nodes in roadmap? Okay, so there's probably going to be some technical stuff here, so let's see if we can break it down. All right. What do the node evolutions here refer to? Let's see, GPT-4o. What are process technology? Oh, thin field effect transistor. Okay, I'll be back in a second. I gotta go see my parents real quick. Yeah,
要不要我们一块儿走过去？
我那太长了。
那走，开车走。
喂，我这还可能给我半个小时。
干嘛呢？
我现在这里了，maybe 20 minutes. Okay. So what is Intel 18A? Foundry Direct Connect 24.
As a reminder, today's presentations include forward-looking statements subject
just gonna
to a
listen to
number
this.
of risks
This.
and uncertainties. More information can be found on this slide and in Intel's filings with the SEC.
I take a breath, I'm not gonna lose.
At Gelsinger.
Hey, welcome to Direct Connect 2024. And I am just thrilled, excited to have all of you here with us today. Last week marked my 3-year anniversary as the CEO of Intel. And when I came back to the job, I said, we have 3 goals. We're going to rebuild this iconic company, the company that Grove, Moore, and Noyce built. Second, we're going to restore the critical role it has and plays in the technology industry writ large. And third, we're going to rebuild Western manufacturing at scale, resilient, sustainable, trusted supply chains. And I think of today as a day 3 years in the making as we open the doors on delivering on that mission. When I came back to Intel in 2021, we presented.
Okay, this is going to be long. I think I'm going to hold off on that for tomorrow. Maybe I have time, maybe not. I have to see. But there's also this thing here. So NA, UV, EUV, so extreme ultraviolet lithography. I don't know what NA stands for. So deep ultraviolet, I think, was, I guess, the previous technology behind 13.5 nanometer light compared to So what is a CD? What is a CD in semiconductor? Okay. What is critical dimension? Stack overflow. Let's see. Is there like a, is there a hardware version of Stack Overflow? Okay. Yeah, this is crazy. Numerical aperture. Ability of an and using bigger mirrors, but the bigger mirrors increase the angle at which would hit reticle, which has pattern to be printed. At the larger angle, the reticle loses its reflectivity, so the pattern can't be transferred by the wafer. Okay, there is a bunch. Oh my god. What even is this? Okay, this is definitely super complex. Okay, so let's take a look here. So, technology questions. Right. So, what is NAEV? So, this is ASML. Okay, so I think planar process. I think we should understand what this is. Explain. Okay, so there's a decent amount of technical stuff here with chemistry. Let's just see if we can break this down. All right. Yeah? Huh? Give me like 15 minutes. Okay, so planar process, let's see. Oh man. Yeah, that sounds hard. Okay. To view a circuit in its two-dimensional projection, a plane, let's align the use of photographic processing concepts such as film negatives to mask the projection of light-exposed chemicals. This allows the use of a series of exposures on a substrate of silicon to create silicon oxide, insulators, or doped regions, conductors, together with the use of metallization and the concept of a p-n junction and surface passivation. Yeah, man, I have no idea what any of this means. Is it a good idea to dive into all of this today? I have no idea. Let's take a look at FinFET then. Oh, okay, so I think this is a 3D transistor, or 3D stack. Okay, so I somewhat understand what this is trying to say. When it says here, plagued by power leakage, I think this means that when you are not using your CPU or your semiconductor, the electricity or power, maybe that's the right or not super technical way to say it, but some type of power is leaking or being used, but your actual CPU isn't really doing anything, or your actual semiconductor isn't doing anything. Now, performance limitations, I don't know exactly what this is referring to. I guess at some point, even if you shrink your device or your semiconductor, the actual performance of the semiconductor doesn't really improve, even though you're adding more transistors or something. Okay, so this is interesting. FinFETs. Oops. These are a new type of transistors. Okay, so what is a gate, source, and drain in transistors? Okay, where's Clyde? Okay, so let's try to understand this though. Basics are the gates. So the gates. So what is a terminal? So gate, source, and drain are terminals of a field effect transistor, right? FETs. So this is Quora. What are terminals of a tran? What does terminal mean in for transistors? So what does terminal mean in the context of transistors? So I think bipolar junction transistor was the one that William Shockley ended up inventing. So in the context of transistors, terminals refer to the electrical connections or point of contact that allow a transistor to interface with the rest of the electronic circuit. So are electronic circuits just a bunch of transistors then? I feel like they can be. There's which is there was something I wanted to ask. All right, so what connects transistors and other components on an integrated circuit? Okay. So integrated circuit metallization. So science behind integrated circuits. Books on integrated circuits. I know, I'm getting super sidetracked here. Let's see if I can find a PDF. Okay, so what is analog? Analog. Okay, so what is analog versus digital? Huh. I guess the signal is analog versus digital. When someone says, okay, what is a signal? Okay, so someone says analog versus digital. What do they mean? So analog refers electronics to electronic systems that have signals that are continuous. Wikipedia. Digital refers to electronic systems that have signals that are discrete. Wikipedia. Oops. Okay, so what does that mean? I guess with digital you have a bit of 0, 1. Example is that digital electronics, so I think phones, computers store information in bits 0, 1, which are discrete. Analog electronics this one. Pressure. Use the angle position needle on the top. So there's a lot of stuff here. It's hard to analog chip. So what is an example of analog computer? Analog computers still used today. So are computers today analog or digital? Okay. So, all right, I kind of understand digital devices, digital cameras, cell phones, internet. Okay, so this is interesting, right? There is take in. Okay, let's see. Okay, I guess a radio frequency signal RF is continuous. I guess so. Our radio frequencies, I guess they're waves, right? They are waves. like sine functions. This picture shows an analog RF receiver that digitizes, converts the continuous signal to 0 or 1s. Okay, so I think with that, I need to go get a little shaving thing from CVS, and I gotta go to sleep soon, so I have to wake up pretty early tomorrow around 5. It's almost 9. Gotta go to sleep. So I'll see you guys next one. Thanks for tuning in. This one is going to be really long. I feel like the Intel, there's going to be a really big learning curve. First, of how the whole semiconductor manufacturing process works, and then understanding some of the technologies behind it, maybe at a high level. I don't have to go super deep, and understanding the roadmap for Intel in the future. I think it's probably the big things. I might do a map of what I want to accomplish with Intel. So I'll do that next one. Peace.